Let us learn about the limits of trigonometric functions. But before that, let us start from the basic identity, that is the reciprocal identity. Sine x is equal to 1 over cosecant x. So if we're going to multiply this, cross multiply, the product will be 1. Next, we have cosine x is equal to 1 over secant x, and we're going to cross multiply. The product is also 1. And for cotangent x, that is 1 over tangent x. Cross multiply, the product is also 1. Also, we can recall the Pythagorean identities. We have the square of cosine x added to the square of sine x is equal to 1. Also, we have the square of tangent x plus 1 is square of secant x. The square of cotangent x plus 1 is the square of cosecant x. Now from these identities, knowing that sine x is equal to 1 over cosecant x, it is also true that sine squared x is 1 over cosecant squared x. So it follows, when you square this must also be squared. So this can be cosine squared x is also equal to 1 over secant squared x. The same is true with cotangent. Okay, so it means to say that if you're going to have different exponents, if I place 3 here, this is also 3, that is also equal to 1. However, we should not get confused that if you use x here as the angle measurement, if this is x, then the other is 2x, then this is not already equal to 1 because 2x is not x. They're not the same. So it must follow always, let's say cosine 5x, then secant 5x must be the other. So if you have 5 here or raised to 5, the product is also 1. Because 5x is also 5x. So it matters that you need to observe the angle measurements. If they are the same, then you can still have these identities. Also, we need to understand that if sine x is multiplied to sine x, then the product is sine squared x. Then it also follows that this is the square of sine x. So we need to understand this again, and as we try to simplify trigonometric expressions. Also, if you have cosine 2x is multiplied to cosine x, then remember x and 2x are not the same, then the product is cosine 2x cosine x. If you're going to multiply x, multiply that to tangent x, the product is x tangent x. So do not think of multiplying x to that of x, and you might think of tangent x squared. Well, that is wrong. It must be x tangent x. Now these are necessary in the operations. Also, if we're going to get the product of sine x plus 1 multiplied to cosine x plus 1, then you do the FOIL method. Sine x times cosine x is sine x cosine x. 1 times cosine x is cosine x. 1 times sine x is sine x. Then 1 times 1 is 1. So the product is sine x cosine x plus cosine x plus sine x plus 1. So as if you're just using the rule of binomial, you are treating this as a, this is also a, so the product is a squared. You see, this is squared. So if you have again, let's say tangent squared x multiplied to tangent cube x, then 2 plus 3 is 5. So you have tangent 5, or that is the cube raised to 5, no? Fifth power of tangent x. So let us begin by understanding the limits of sine and cosine function. But first we need to understand that the domain of the sine and cosine is the set of all real numbers. Therefore, if that is a set of all real numbers, then direct substitution can be done. So let's have number 1. Limit of cosine x as x approaches 0 is 1. Yes, that is 1. Because 0 is also 2 pi. So here is 0. Coordinates 1, 0. And cosine is the x coordinate. Going back to unit circle. So cosine 0 is 1. Number 2, sine x, where x is 0. So sine 0 is 0. Okay, so here, what about limit of the square of cosine x as x approaches pi? So that will be cosine pi, then we need to square cosine pi. And since cosine pi is -1, so square -1, the answer is 1. On the fourth example, we're going to have the addition. Let x be pi over 2, so we have cosine pi over 2 plus pi over 2. Cosine pi over 2 plus pi over 2 is cosine pi. Okay, so as if 1/2 plus 1/2 is 1, so that is 1 pi or pi. And cosine pi is -1. Next, we have limit of sine x plus pi over 2. Let x be pi over 2, so we have sine pi over 2 plus pi over 2. So that will be sine pi. Sine pi is 0. So we have here the next example. We're going to substitute. Let x be pi over 3. So we have sine pi over 3 plus cosine pi over 3. So sine pi over 3 is equal to square root of 3 over 2. And cosine pi over 3 is 1/2. So our answer is square root of 3 plus 1 over 2. So the next example, that is a division. So that will be cosine pi over 6 over sine pi over 6. Cosine pi over 6 is the square root of 3 over 2 divided by 1/2. Cancel 2 here. The answer is square root of 3. Next, we have the cube of sine x. Let x be 3 pi over 2. So we have sine 3 pi over 2 cube of that. And sine 3 pi over 2 is -1. So we have -1 quantity raised to 3. The answer is -1. So here, the next example, let x be 3 pi over 2. So we have sine 3 pi over 2 times cosine 3 pi over 2. Sine 3 pi over 2 is -1. Cosine 3 pi over 2 is 0. So -1 times 0 is 0. So we have the next example. Let x be negative pi over 4. So we have sine negative pi over 4 minus cosine negative pi over 4. Okay, so where can we find negative pi over 4? That is on quadrant 4. So we have x that is positive and y that is negative. So it means to say that sine negative pi over 3 is negative square root of 2 over 2. So minus positive square root of 2 over 2. So that will be negative 2 square root of 2 over 2 cancelled. 2 here, our answer is negative square root of 2. So this will be negative square root of 2. That will be the limit. But when it comes to the limits of second function, we need to go back and recall limit of secant x. As x approaches c is secant x, where secant x is equal to 1 over cosine x, right? By reciprocal identity, so that will be 1 over cosine c. Provided that cosine c here, so there is a condition. Provided that this must not be equal to 0. Well, if that will happen, then the limit will not exist. Take note that the domain of the second function disregards all multiples of pi over 2. Why? Because this is pi over 2, this is 3 pi over 2, and take note the coordinates here. So we have 0, 1, 0, negative 1. So cosine is x and it becomes 0, so it means to say we are going to disregard all multiples of pi over 2, just like negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and all possible multiples of pi over 2, because this will make secant x undefined. At the same time, the limit will not exist. But I will also explain to you why is it that the limit does not exist in that case, and that will be on our next topic. So let's have examples. First, we have the limit of secant x is equal to, as x approaches 0, will now be equal to secant 0, which is equal to 1 over cosine 0. So the answer is 1, because cosine 0 is 1. So 1 divided by 1 is 1. Next, we have limit of secant x as x approaches pi over 4, and that is equal to secant pi over 4, which is equal to 1 over cosine pi over 4. And since cosine pi over 4 is square root of 2 over 2, okay, so our answer is square root of 2. How did it happen? Okay, if you're going to have get the reciprocal of square root of 2 over 2, so we have 2 over square root of 2, then rationalize. Okay, so we have 2 square root of 2 over 2, so cancel 2. The answer is square root of 2. Next example, we are going to substitute pi over 3 from secant x, so we have secant pi over 3 square of that, which is equal to 1 over cosine pi over 3, then get the square. Cosine pi over 3 is 1/2, so we have 1 over 1/2 square, that will be 2 squared, so the answer is 4. So next we have the product of 2 and the square of secant x. Let x be pi over 6, so we have 2 times secant pi over 6 square, and that will be 2 times 1 over cosine pi over 6 quantity square. So we have 2 times cosine pi over 6 is equal to square root of 3 over 2. So that will be square root of 3 over 2 square of that. So 2 over square root of 3 quantity square. We're going to square 2, so we have 2 times 4. And square root of 3 is 3, so we have 3 here. Our answer is 8 over 3. So next we have limit of secant x as x approaches pi is equal to secant pi, which is equal to 1 over cosine pi, and cosine pi is negative 1, so 1 over negative 1. Our answer is negative 1. So the question here is, when will the limit of secant x does not exist? So when will that happen? Okay, that is usually the question, right? Take note that in the domain of secant x, we disregard pi over 2, 3 pi over 2, and all the multiples of pi over 2. And take note that this one is a two-sided limit. This is a two-sided limit. We don't see any negative, positive symbols. signifying left or right. So it means to say this will be automatically DNE, or it will not exist anymore. The reason will be explained as we go through, um, but one of the reasons is because left or right of these two does not exist. Okay, so since left or right does not exist, then the limit, the two-sided limit, will not exist too. So now let us talk about the limits of cosecant function, and cosecant x is 1 over sine x. So the condition here is sine x should not be 0. So in the substitution, sine c should not be 0, because 1 over 0 will now give you undefined, okay, and the limit will not exist. Now, in the domain of cosecant function, we need to recall that we can use any real value x okay, except all multiples of pi. So we disregards negative 2 pi, negative pi, even 0, because 0 and 2 pi are coterminal, okay? 2 pi and all multiples of pi, we are going to disregard that. So let us have examples. Number 1, so we have limit of cosecant x as x approaches pi over 2, and that will be by direct substitution cosecant pi over 2, which is equal to 1 over sine pi over 2. And pi over 2, sine pi over 2 is 1. So 1 divided by 1 is 1. Next, we have limit of cosecant x as x approaches negative pi over 6. So that will be cosecant negative 5 pi over 6, which is equal to 1 over sine negative 5 pi over 6. So where can we find negative 5 pi over 6? And the reference angle of this angle in standard position is 30. 30 times negative 5, this is equal to negative 150 degrees, and we can find it on quadrant 3. So sine, okay, the value of sine must be a negative. So that will be, so sine negative 5 pi over 6 is equal to negative 1 half. Okay, reciprocal of negative 1 half is negative 2. Our answer is negative 2. Next, we have limit of cosecant x as x approaches pi over 3. Substitute x, okay, that will be cosecant pi over 3, and that is 1 over sine pi over 3. So our answer here is 1 over square root of 3 over 2, because sine pi over 3 is the square root of 3 over 2, and that will be 2 over square root of 3 and rationalize. So 2 times square root of 3, we have 2 square root of 3, and square root of 3 times square root of 3 is 3. So our answer is 2 square root of 3 over 3. Okay, so next we have finding the limit of the square of cosecant x as x approaches pi over 4, and that will be cosecant pi over 4 quantity squared is equal to 1 over sine pi over 4 quantity squared, and that would be 1 over square root of 2 over 2 square. The reciprocal of square root of 2 over 2 is 2 over square root of 2. Then you have to square it. Square 2 gives you 4. Square root of 2 is 2. So 4 divided by 2 is 2. So the limit is 2. Okay, so next we have limit of 3 times the square of cosecant x as x approaches pi over 6. So we have 3 times cosecant pi over 6 quantity squared, and that will be 3 times 1 over sine pi over 6 squared. Okay, so that will be equal to cosecant pi over 6 is equal to 1 half. So we have 3 times 1 half quantity squared. So square of 1 half is 1/4. So times 3 is 3 over 4. So our answer is 3 over 4. Okay, so we're going to repeat the solution, and that is equal to 3 times 1 over 1 half quantity squared is equal to 3 times 2 raised to 2, because 1 divided by 1 half is 2, so 2 squared is 4. 4 times 3 is 12. So 12 must be the limit. If we are going to look into this number, then these are multiples of pi and these are two-sided limits. And we already identified the domain of cosecant function that it disregards all multiples of pi. Therefore, when we talk about the two-sided limits, that is cosecant and this is negative pi, because if you're going to substitute that, that will be cosecant negative pi. The other is cosecant 4 pi cube. Okay, and since that is 4 pi and that will make the function undefined, therefore the limit will not exist. Okay, and we will have a general explanation of that when we move to our next topic about infinite limits. Now, if we understand the limits of tangent function, we first take a look on its ratio identities. Identity that is tangent x is sine x over cosine x. And with this idea, cosine c or cosine x should not be 0. Okay, so where will that cosine function become 0? So that will happen when we talk about the multiples of pi over 2. Because if we take a look into the unit circle, going back to the unit circle we know that the coordinates here is 0, 1, and the other are 0, negative 1. And negative for x tells you that that is cosine. It will become 0. Okay, 0 for cosine. And the angle measurement for this is pi over 2. So if you move here, 3 pi over 2. 3 pi over 2 is 270 degrees and pi over 2 is 90 degrees. Therefore, we will disregard all multiples of pi over 2 because tangent will become undefined. And at the same time, the limit will not exist in the two-sided limit. Okay, now let's have an example. First, let's have limit of tangent x is equal to, as x approaches pi over 4, we can have direct substitution because pi over 4 is part of the domain. So our answer is square root of 2 over 2, that is sine pi over 4, and cosine pi over 4 is square root of 2 over 2 also. The answer is 1. So here we have tangent pi over 3, and that will be equal to, that is equal to sine pi over 3 over cosine pi over 3. Okay, sine pi over 3 is the square root of 3 over 2, and cosine pi over 3 is 1/2. So the answer is square root of 3. Okay, next we have square of tangent x. So we have tangent pi over 3 square, and since tangent pi over 3 is already solved and that is the square root of 3, so we're going to substitute and then we square. So our answer is 3. Next we have 5 constant 5 multiplied to the square of x. As x approaches pi over 6, so we have 5 times tangent pi over 6 raised to 2 is equal to 5 times sine pi over 6 over cosine pi over 6 quantity raised to 2, and sine pi over 6 is equal to 1/2, and cosine pi over 6 is square root of 3 over 2, then square that, so that will be 5 times 1 over square root of 3. We can just cancel out 2 here, so that will be 5 times square root of 3 is 3, so 5 times 3. Our answer is 5 over 3. Okay, so in the next example, limit of tangent x plus pi over 3 as x approaches negative pi over 3 is equal to tangent negative pi over 6 plus pi over 3 is now equal to tangent negative pi over 6 plus pi over 3 is that is equal to pi over 6. So we have tangent pi over 6, okay, and we already have the tangent pi over 6 on the previous example, and that is equal to 1 over square root of 3. So rationalize that. So times square root of 3 times over square root of 3. So our answer is square root of 3 over 3. And again, when will we have a limit that will not exist on tangent function? That will happen first by observing the final evaluation. So if you try to substitute here on the first, then you will have tangent negative pi over 2. And take note that negative pi over 2 is still a multiple of pi over 2. The negative sign is just signifying clockwise rotation, but it remains to be the same when it comes to the values, because cosine negative pi over 2 is still 0. Therefore, the limit of this two-sided, this one is two-sided, okay, does not exist. Now here, even if you see this one as pi over 4, but if you're going to substitute that, okay, and try to observe the final expression or the value, it becomes pi over 2, because tangent pi over 4 plus pi over 4, or pi over 4 plus pi over 4 is pi over 2, and this should not be should not happen, no, when it comes to evaluation. So the limit does not exist. Okay, so we're here on the last function, and that is cotangent function. So how do we evaluate the limit of cotangent function? Again, cotangent x is cosine x over sine x, and the denominator sine x, or in the evaluation sine c, should not be equal to 0. And when will that happen? That will happen if you have the multiples of pi, because sine pi, negative pi, sine 2 pi, sine 3 pi, 4 pi, and all multiples of pi, okay, and multiples of pi, and sine function becomes 0. So we will disregard that, because if you try to use that, then the limit does not exist in the two-sided limit, and cotangent x, where x is a multiple of pi, okay, then it is undefined. So let us have examples. Okay, so we begin by finding the limit of cotangent x as x approaches pi over 3, and that is equal to cotangent pi over 3, okay, by reciprocal identity or ratio identity, that is cosine pi over 3 over sine pi over 3, and that will be equal to cosine pi over 3 is equal to 1/2, and sine pi over 3 is square root of 3 over 2. So this will be 1 over square root of 3. Then when you rationalize that, so times square root of 3 over square root of 3, our answer will be square root of 3 over 3. Now the second is very simple, because cotangent pi over 4, where cosine pi over 4 is square root of 2 over 2, and sine of pi over 4 is also square root of 2 over 2. So this is simply equal to 1. Next, we have limit of cotangent x plus pi over 3 as x approaches negative pi over 3. So we have to substitute. So we have cotangent negative pi over 3 plus pi over 6 plus pi over 3 will now be equal to cotangent negative pi. Sorry, that will be positive. That is positive pi over 6. Okay, and that is equal to cosine pi over 6 over sine pi over 6. So cosine pi over 6 is equal to square root of 3 over 2, and sine pi over 6 is 1/2. So you can now cancel this. Okay, our final answer is square root of 3. On the next example, we are just going to substitute pi over 6. So 3 times cotangent pi over 6 cube is equal to 3 times cosine pi over 6 over sine pi over 6, the cube of that, is equal to 3 times, well, cosine pi over 6 is equal to square root of 3 over 2, okay, and sine pi over 6 is 1/2 to get the cube of that. Okay, so we now have 3 times square root of 3 cubed, because we can now cancel 2 and 2 here. Square root of 3 over 2 divided by 1/2 is square root of 3. Okay, so we observe cube. So we're going to get the cube of square root of 3 by expansion for us, so for you to understand as well. So we have 3 times square root of 3 times square root of 3 times square root of 3. So square root of 3 times square root of 3 is 3. So we have 3 times 3 times square root of 3. So that will be 9 square root of 3. So the answer is 9 square root of 3. Okay, now on the last example, we now have getting the square of cotangent x as x approaches pi over 3. So that is cotangent pi over 3, the quantity squared. And since cotangent pi over 3 is already solved, that is the square root of 3 over 2. So we have square root of 3 over 3 square. Get the square of square root of 3, that is 3 squared 3, that is 9. And the lowest term is 1/3. So the limit is 1/3. Okay, so in this case, when will the limit of cotangent function not exist? Or kailan siya hindi mag-exist, okay? That will happen if you're going to have the final substitution. So if you try to observe here and you try to substitute, here it will give you cotangent at 2 pi. The other will give you cotangent at negative pi. This will be the final evaluation. However, you observe that these are multiples of pi. Okay? N multiples of pi. So ibig sabihin nito, hindi natin siya pwedeng gamitin in the evaluation kasi ito ay undefined in the evaluation. Okay? But when it comes to the limit, well, the limit does not exist now. Okay? That is for two-sided limits. But again, when we proceed to the limits of infinity, then we'll again dissect the limit on the left and the limit on the right, and we'll try to know why is it that the two-sided limits of tangent, cotangent, secant, cosecant does not exist on these critical values. Okay? But the sine and cosine function, the limits, okay, will always exist for whatever is the value of x because domain has no restriction. Thank you.